I'm trying not to zoom too much, right? But here was my original problem. This was the second problem I did today. So y is tan of x is sine of x over cos of x, right? That's a quotient, so I'm using the quotient rule there.
Can you explain the circle C and S?
Yeah, so I'm taking the derivative of cosine, I go past the negative in the alphabet. So derivative of cosine is negative sine. If I start on sine, I don't go past the negative, so derivative of sine is cosine. It's just a shortcut way. It doesn't make any sense mathematically. It's just a way to remember it.
What's the N?
Negative.
So,
Derivative of cosine is negative sine. So you see, when you move from C to S, you go past the negative. When you move from S to C, you don't go past the negative. So derivative of sine is positive cosine. You'll see something similar with arc cosine and arc sine when you do those derivatives, right? Inverse trig functions. So the result there we want to memorize, right? So that adds to our shortcut list, yes? Yeah, you with me? It's adding to our shortcut list, right? Derivative of e to the x is e to the x. Derivative of ln of x is 1 over x. Derivative of sine, cosine. Derivative of cosine, negative sine. Derivative of tangent, secant squared. Of course, what should you do? The rest of the trig functions, right? Cosecant, secant, cotangent, right? And then there's 3 more for your shortcut list. Nice. Let's do a tangent line problem. Sure. I'm in no rush. No rush at all. Grace is here. Everybody's here, but Thomas. I don't know if Thomas exists anymore. I think that on the homework I just returned, the biggest issue was, I guess you didn't read directions. I wanted to do the last 3 problems, it asked for the domain of the function and the derivative. In the first 2 problems, I had about 3 or 4 of you doing the tangent at the point instead of the general derivative, right? So just so you know, we really probably always want the general derivative first before we go find a slope. So if you do that limit with a specific point in it, you're going to arrive at a number, whereas I want you to arrive at a function, right? Is that making sense? About 4 of you did that. Yes?
oh,
Okay. Yep. Okay, go back down, yes. And you could take photos anywhere. Grace, yes? Yes. Yes, so that's the formula, okay? So just let me go back to my general formula here. Here's my formula for quotient rule. And it is strange. And the way I would convince you is I would do the proof like I did the proof of the product rule. So if I did this proof with my limit, you'd see, oh yeah, that's the derivative. So it's kind of like either do the proof, right, or accept. I mean, I could do the proof for you, but it's exactly the same as what I did before, where I added 0, so I could factor out and do, and you know. So it's weird, right? I agree. It's weird. It's strange. In fact, I used to hate when I was a student in Calc 1. What year was it? 90s something. I hated it. So I turned everything into the product rule. I would say if I had y equals f over g, I would change it to f times g, g to the -1 power. But I can't do that without the chain rule. So once I learned the chain rule, I realized I could do everything as a product rule. Okay, but you're not ready. I'm going to start the chain rule. I'm going to have the chain rule done next week for sure. Once we get the chain rule, and I want you to be caught up, right? I want you to be completely caught up. Make sure you're doing lots of product rule, quotient rule problems, right? So that you're ready for the chain rule. Okay, next problem. Let's do 27. First derivative and second derivative with the chain rule, right? So I've got x squared. Actually, what do I like better? Doesn't matter. 27. X squared over 1 plus 2x. X squared over 1 plus 2x. And we want to find y and y prime. Sorry, y prime and y double prime. So second derivative just simply means after you get your first derivative, do a derivative again, right? All right, quotient rule. Yes, you ready? What's the upstairs function of y? X squared, right? What's the derivative? Yes? 2x, nice. Diego, I got you. Downstairs function, 1 plus 2x. Derivative, 2, right? Just an mx plus b. And the downstairs function squared is 1 plus 2x. I'm gonna try and, I'm not gonna FOIL things out, right? A couple of you did that as well on your derivatives. Don't FOIL things out. Keep them factored. Why? Because when things are factored, it's easy for me to find critical values. Okay, chapter 4. Here we go. Y prime is 2x times 1 plus 2x, right? I'm doing this piece first. Yes? Minus 2x squared all over 1 plus 2x quantity squared. Now, on this one, you're going to be tempted to distribute. I would rather you factor. This one is easy enough to distribute, but I'd rather you factoring even when it's this simple, okay? So notice I can take out a 2x, right? And what's left? 1 plus 2x minus x. Make sure you see that. Don't let me go too fast. I am your Uber driver. You tell me to go under the speed limit, I'm kicking you out. But I'll go to speed limit. So I can simplify that, yes? I get 2x times 1 plus x, yes? And now I'm ready for my second derivative. How are we doing? We okay here? Yes, everyone okay? Everyone got there? Rosie, yes, thank you. Anybody else? So first of all, notice there's a 2x here and a 2x squared here, right? And I definitely can see that if I distribute back, you see the 2x times the 1 plus 2x, and you see the 2x times the x, right? It's a lot of times I've noticed my calc students, it's easier after I factor, it's easy to see how I factored by distributing it back. And you should do the same. When you factor something on a test or a quiz, make sure it worked. Don't just move ahead, right? One more time. Originally, the downstairs was, yes, 1 plus 2x. It's 1 plus 2x times 2x minus 2 times x squared. Right, that loop. Yes? Is that Ian?
Yeah.
You with me? Okay, so I've got a product rule, right? That's this loop, yes? So I'm multiplying these two terms, these two factors together. There it is. Yep. Minus these two factors together. There it is. Right? That's the rule. And then I want you to factor. You're usually gonna have a factor. This one is easy enough for me to distribute, but sometimes it gets so messy when I distribute. It's better for you to factor. Okay? All right, we're ready for our second derivative. Yes, you with me? Ready for my second derivative. So, what am I going to say? Well, f is my new numerator, which is 2x times 1 plus x. That one, instead of me doing a product rule, I'm going to distribute, okay? So what do I get? I get 2x plus 2x squared, right? So my derivative is easy now. What do I get? 2 plus 4x. My downstairs function is 1 plus 2x quantity squared. Guess what? To get that derivative, I'm not ready for the chain rule. I'm going to FOIL it out. I get 1 plus 2x times itself, right? Which is what? 1 plus 4x plus 4x squared. And that derivative is 4 plus 8x. Make sure you're with me here. Yes, we okay? You're just copying, yeah? Yep. I often, even today, will forget my g squared if I don't write it down in my process here. So I want to make sure I write down my g squared, right? Divided by g squared, which is 1 plus 2x quantity to the fourth, right? You agree? Yeah, how we doing? We okay? Yeah, Rosie. How did I get the for g prime? Yeah, so you agree with the foiling, right? And then when I do my derivative, derivative of 1 is 0. Derivative of 4x, mx plus b is 4, right? Derivative of 4x squared is 8. Bring down the 2, 8x, right? Yes, you with me?
Yeah.
Nice.
Do you not want us to FOIL g squared?
No. Try and not FOIL unless you absolutely have to, right? It is a 4-letter F word, by the way, FOIL, right? We're trying to factor, not distribute, okay? All of Calc 1, okay? So I'm ready for y double prime now, right? What's my my first product is here, yes? I get 2x times 1 plus x. Oh, sorry, I'm backward, aren't I? It's a quotient rule, right? Like my first one is here, right? I get 1 plus 2x quantity squared times 2 plus 4x minus, now this one, right? Minus 2x times 1 plus x times 4 plus 8x. Yes, 1 plus, yep, 1 plus 2x squared, yep. That's from my green box, yes. And this is the blue box, yes. All divided by 1 plus 2x quantity to the fourth. Do you see what I mean about this? How nasty this top is? Do I want to FOIL distribute here? No, I want to factor. I can see a common factor of 2 in the first term and a common factor of 4 in the second term. So I'm going to take those out first.
And what was the purpose of spoiling it in the process?
Up here, we don't know how to take a derivative. This one I didn't want to do the product rule. I'm too lazy. And this one I don't know how to do this yet. That's the chain rule. Why do I know this is the chain rule? Who remembers what I said? Why do I know that's the chain rule problem? You don't even know what the chain rule is, but like I told you, when you're looking at the inside function, right? What you see the inside function there? What's the derivative of the inside function? 2. If it's 1, I don't need a chain rule. If it's anything else, I need the chain rule. All right, I see that I could take out a 2 from this green piece. And I get what, 1 plus 2x, right? And I can take out a 4 from the blue piece. Does everyone agree? Hello? Does anyone agree? Yes, Grace. Yeah, so I took out a 2 here, right? You see a 2 and a 2? There's the 2. And then here I took out a 4 and a 4, so it became -8. It was -2. Yeah, we okay? I can't. There is no common factor there. Yeah, but right, 4 times 3 times 2 is 24, right? If I'm factoring, right, I only take out a factor from where I can take out a factor, right? So I could take out a factor of 2 here, but not from the 3, right? Yes, you with me? I only take out factors from where there are matching factors. So, go ahead, yes? I didn't. I took out a 4. There's a 4, right? You agree that 4 times 1 plus 2x is 4 plus 8x, right? Yeah. So, and then I multiplied it to the 2. So I took out that factor of 4 and multiplied it to the 2. Yeah. All right, now what can I take out? Do you notice anything similar? There's a 2 times a 1 plus 2x that could come out. It's in both of them, right? You see it? There's a 2 and a 1 plus 2x. There's a 2 and there's a 1 plus 2x. So what's left over upstairs? I've got a 1 plus 2x quantity squared minus 4x times a 1 plus x. All over 1 plus 2x quantity to the 4th. Everybody with me? What I factored out is in green, yes? So what's left in black is here, right? 1 plus 2x quantity squared. There's 2 times 4 is 8, so there's a 4 left. There's the x left, and there's that 1 plus x left. You're all making me nervous with the factoring. You better practice, okay? All right, so let's keep going. Am I factored yet? Nope. Where can you tell I'm not factored? Yeah, that square bracket is not factored. I have to get that ready to be factored. So I need to do some distributing, right? First of all, this cancels with this power, right? So far I have 2 over 1 plus 2x to the third times whatever's in my square bracket here, which is 1 plus 4x plus 4x squared minus 4x minus 4x squared. Right? So I FOILed this, I distributed this, yes? Look at what goes away. Huh. Look at what goes away. Just about everything. The 4x cancels, the 4x squared cancels. And there's my second derivative. If I'm doing an odd problem in the book, I've got the answers, odd answers, right?
That's why prime.
Say again?
That's why prime.
Oh yeah, thank you. Y double prime, thank you. If I'm doing an even problem in the book, I can use Symbolab. I use Symbolab a lot. So let me do this on Symbolab real quick. Can I go to another page? You need a minute, okay? Sorry. Oops, sorry. Now, when you rewrite your notes, don't just copy the notes. Do the problem again. Do the problem on your own, right? I'd rather you, instead of copying me, say, what's the numerator? What's the derivative of the numerator? I'd rather you be finding the derivative while I'm saying it, right? Copying is not as good as actually doing it. You can do all of this. All right, let me go to Symbolab. I need to look at my original function. I'll come back to it if you need me to. X squared over 1 plus 2x. I used, when I was in grad school, I used Wolfram Alpha. That's what got me through school. So Symbolab.com. I've got a derivative function here, right? ddx is my derivative function. Yes? Where did I hit it? Sorry. Oh, there it is. ddx of ddx. I'm doing second derivative. And what was my original function? Don't tell me. I forget already. X squared over 1 plus 2x. So x squared divided by, oops. Divided by 1 plus 2x. Oops. Good, Robert. Here we go. There it is. It shows you steps too. You can see it. There's my first derivative, and then it took the derivative of it, and I can show the steps over here on the right. Not bad, right? Symbolab. S-Y, like symbolic? Yep. Symbolab. Symbolab. Symbolab.com. Wolfram Alpha will do it. I'm sure there's several others. This one almost will do every problem we have in Calc 1 and 2. I don't know if it handles Calc 3. Calc 3 is multivariable, so no longer just X and Y. We start to go into 3D and more. Nice. Let's do another one. Let's find a tangent line here. Let's do number 29. Very similar to the one we just did, but we're just adding a tangent line to it, okay? It talks about a normal line. I don't know if you know what a normal line is. A normal line is a perpendicular to a tangent. Almost like if you could think of a snail moving, you can see its right antennae kind of standing up. So the normal line is the tangent, is perpendicular to the tangent, but I never ask about it, okay? Let's do 32, actually. That makes it, I think it's a little bit more interesting. So 32 at the point 4 comma 2/5, right? 4 comma 2/5, yes? So I want the tangent line, square root of x over x plus 1. Here we go. So y equals square root of x over x plus 1. And we want the tangent line at 4 comma 2/5. I'd rather no decimals. I definitely don't want any estimating numbers. So if I tell you square root of 2, don't tell me 1.4 or something, right? Just leave it as square root of 2, right? So we agree with 4 2/5, by the way? Yeah, you can see it. You can plug it in, make sure it works, right? So what do I need? I have a point. What do I need? A slope. How do I get a slope? I need a derivative. So I'm going to get this derivative using the quotient rule, right? What's my upstairs function? Good. Square root of x. What's the derivative? Good. Good. Downstairs function, x plus 1. Derivative of that, 1. Everybody okay here? My remote class talks more than you do. My remote class talks more, and I can see their faces. My face-to-face class doesn't talk, and I can't see their faces. It's funny. It's like driving on the parkway and parking in the driveway. Say again? Yeah, chain rule, no. Notice the function upstairs, the inside is x, right? And the derivative of the inside is 1, so I don't need the chain rule there. Right? Chain rule is section 3.4. We're on section 3.2. I really already did section 3.3. That's just all the trig derivatives. So we're just going to jump into 3.3 today and just do some problems. I taught you everything you need in that section.
This is another quotient rule?
Yes. How do I know it's a quotient rule? Fraction. The function is a fraction. That you can verify the quotient rule? Yes, you could prove it. So g squared is what? X plus 1 quantity squared. All right, let's take a look at our loop, right? So I need this piece first, yes? So y prime is x plus 1 over 2 square roots of x minus square root of x, all divided by x plus 1 quantity squared. Is everybody with me? Since I'm just finding a slope at 4, I could plug in right now, but I want you to make things look pretty. Pretty is subjective, right? So, but it means clean up the fractions. So I'm going to multiply everything upstairs by 2 rad x, everything downstairs by 2 rad x. So I get x plus 1 minus 2x. Agreed? So it looks like I get 1 minus x upstairs, right? And that's nice, that's factored, that's what I want. I want something completely factored. Right? Kind of an understood set of parens upstairs, right? Well, I have a point, 4 comma 2/5. I have a derivative now, so now I can find a slope, right? So my slope is going to come from y prime at 4, right? So everywhere there's an x, I'm plugging in a 4. So I get 1 minus 4 over 2 square roots of 4 times 1 plus 4 quantity squared. Negative 3 over 4 times 5 squared. So negative 3/100ths. Right? 5 squared is 25, yeah? 4 times 25 is 100, yeah. Yes? Originally, they had asked for the tangent line at x is 4. Yeah. Now, you can check your derivatives, right? You can check that you have your derivatives correctly on a test by picking any number in the domain, pick smart, pick wisely, right? And then graphing the function and the tangent and make sure that they look like they're doing what they should do, right? So on this midterm, you should know all your derivatives are right. It takes more time to check everything, so you make sure you practice, and then on the test, you just start writing like a mad person. Shards of pencil and paper are flying in the air. You got a bunch of them sharpened on the table because in case you break a couple or are attacked, you have a weapon, right? Your formula sheet is nice and clean and ready, so you can look at that. All right, we're ready for our tangent line, yes? So what do I need for my tangent line? I have y minus 2/5 equals negative 3/100ths times x minus 4, right? Everybody knows where this is coming from, yes? Everybody's comfortable with the equation of a line. So y minus 2/5 equals negative 3/100ths x plus 12/100ths. It does reduce. I will probably reduce it, but I'm going to move my 2/5 over. Right, so what do I get? Help me, 3/25ths. So final answer, y equals minus 3/100ths x plus 13/25ths. What do I want to do? Graph it, right? Anybody need a minute before I go graph it? Yes, no problem. Okay. Everybody okay? Nice, I gotta remember my original function. Was it rad x over 1 plus x? Is that right? Rad x over 1 plus x? Yeah. So, Desmos y equals square root of x divided by 1 plus x. I've got the point 4, comma, 2/5. Nice. And y equals negative 3 over 100 times x. Help me, plus 13/25? Oh yeah. It's hard one to see, but the ones that are on your test will be clearer. But this is definitely true. Good, let's take a 10-minute break. About trig derivatives. The way that I found the derivative of tangent with secant squared is the way you're going to prove all of the others, right? But I'm just going to write them down now. So if y equals sine of x, right? We said y prime is cos of x, yes? If y equals cos of x, y prime is negative sine of x. If y equals tan of x, y prime is secant squared x. We did that one today with the quotient rule. The other three you should do with the quotient rule. If y equals cotan of x, y prime is negative cosecant squared of x. If y equals secant of x, y prime is secant x tan x. And if y equals cosecant of x, y prime equals minus cosecant cotangent. Cosecant x, cotan x. So you can see kind of a similar, a little bit of a relationship there. But again, these should all be verified by you using quotient rule, right? Do you want to do one of them? Let's do the secant, okay? Let's do the secant. You already saw me do tangent today, right, with the quotient rule. Let's do secant. So all of our trig shortcut, our derivative shortcuts, right, are going on our formula sheet, yes? Definition of the derivative as a limit on our formula sheet, right? What else? Everything. Put everything on it. Put problems on it. I don't care what you put on it, right? Inspirational lyrics. I don't care. Anything you want. All right, let's prove this one. Question? What's that? Need a second? If you remember me showing the book, the front page is one thick blue page. It's everything from pre-cal. The back has got 4 pages. We're already on the second page of things we should have memorized, right? Of that back page, which is the derivatives.
You said you did it by using the what?
Quotient rule. Yep. Okay, we ready? Okay, so y equals secant of x which is really what? 1 over what? Cosine, yeah. So our top function is 1. The derivative of 1 is 0, right? The downstairs function is cos of x. The derivative is minus sine of x, all over cos squared of x. right? Downstairs function squared. Yes, everybody with me? So I need this quotient loop with a negative, right? But you see my first term is 0 anyway, yes? Yep. So I get y prime is 0, double negative is plus sine of x all over cos squared of x. Now I know what I'm trying to get to, so I got to think a little bit here, right? I'm going to rewrite my denominator as sine of x over cos of x times cos of x, right? So I can see that my sine over cos is tangent and my 1 over cos is secant. So there it is, secant x, tan x.
So again, we use the quotient rule, so the derivative of the fraction is not anything but one.
So you're talking about the chain rule piece when the inside function, notice the inside function here is x, right? Sorry. The inside function here is x, and the derivative of x is 1, so I don't need the chain rule. In fact, we have been doing the chain rule all along. You just don't realize it. Chain rule says take the derivative of the outside function, evaluate it at the inside function, and then multiply that by the derivative of the inside function. But that piece has been left out because when you multiply by 1, you don't change anything, right? We're gonna do the chain rule on Tuesday, okay? So lots of practice before Tuesday. Please get all this product rule, quotient rule, derivatives, get it all down. Because from Tuesday on, we're doing the chain rule every time we do a derivative. All right, let's do a problem. Sure, where are you?
So is the numerator right there sine of x?
Yeah, I don't know how I erased it, but I did. Inks. Yeah, the sine over cos is the tangent, and the 1 over cos is the secant, right? I'm worried about the trig, but I'll find out today if you can do a simple trig problem on the quiz. Trig will haunt you in Calc 2. Haunt you. Forget Calc 2 if you don't like trig. I don't know how anyone could. We once interviewed a possible professor of math here, and they said their least favorite class was trig. Everyone just made the same sound that you made. It's like, how could you not love trig? If you're a real nerd. All right, let's do a couple problems here. Oh, here, let's do a tangent line with y equals secant of x at pi over 3 comma 2, right? So y equals secant of x at, and I want the tangent line at x equals pi over 3. Well, they told me it's pi over 3 comma 2, but I want to make sure I agree, right? So I don't think in secants, I think in cosines, right? So I know that y equals 1 over cos of pi over 3, and of course cos of pi over 3 is 1/2, so I get 2. Agreed? So now I want to get the derivative, but I already know the derivative and I've got it memorized. I know that y prime is secant x tan x. Yeah? So I can get my slope of y prime at pi over 3. So I get secant of pi over 3, which I already know is 2, times the tangent of pi over 3. So secant of pi over 3 is 2. We already figured it out. Tangent of pi over 3 is I forget. It's red 3, right? Yeah. Good. Tangent line. Y minus 2 equals 2 red 3 all times x minus pi over 3. So y minus 2 equals 2 red 3x minus 2 pi red 3. Sorry, yeah, 2 pi red 3 over 3. I'm going to add 2. Which is what, 6? There's my tangent line. Right, when I'm doing these, you're not copying me. You're basically racing me, right? You're doing the algebra 1 at the same time I'm doing it. That's what I'd like to happen, right? Let's graph it. Right, so on your calculators, yes? Y equals secant of x. And I had the point pi over 3, yes? Comma 2. Nice. That's good. I see definitely a positive slope for my tangent, right? And what seems to be a negative b value, which I agree with, right? So I got my tangent line y equals, what was it, 2 square roots of 3?
Yeah.
2 square roots of 3 times x plus 6 minus 2 pi square roots of 3. Is that right? 2 pi square roots of 3 all divided by 3, yes? Bang. Love it. How we doing? Okay? Anybody graph it? And you can see it on the calculator. You can see that you got the right derivative. You got the right tangent. Yes? Good. Let's do another one. They're boring. It's okay. Let's do 5. Y equals secant tangent. Let's get the derivative of that, okay? So product rule, right? First function is secant of x. What's the derivative of secant? Secant x tan of x. Second function is tan of x. What's that derivative? Secant squared of x. Product rule. It doesn't matter which diagonal I do first with the product rule, right? Because it's plus in between, right? But it looks like I get for y prime, I get secant x times secant squared x plus secant x tan x tan x. I can clearly factor out a secant, right? So I get secant x times what's left over, which is secant squared x plus tan squared x. I'm gonna cheat on these a little bit. I don't know if I can do a trig identity here. So I'm gonna cheat a little bit. I'm gonna look at the answer. That's what they have. So I could play around with, I obviously can't do that on a test. I can play around with identities. What are some of the trig identities we have memorized? Sine squared x plus cos squared x equals 1, right? If I divide everything here by cos squared, right, what do I get? I get tan squared x plus 1 equals secant squared x. So you could see I could put this in, right? I could substitute in for secant squared here, right? You see that? And then so what would I get for y prime? I'd get secant x times tan squared x plus 1 plus tan squared x. And to me, that looks a little bit simpler. 2 tan squared x plus 1. So, but I don't know if the book does much with a lot of trig identities, but you certainly could try it, right? You could try one. Yes, would I accept both answers on this one? Yes. 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 How are we doing? We okay? Easy, right? Nice. Well, I don't know if I want to do anything else today. We're gonna take a quiz now. A little early, but that's okay. Anybody have any problem you want me to do before we take the quiz? Anything from homework, anything from past exams? You got homework due on Tuesday, yes? When you hand them in, will you keep them in order, please? Put the problems in order when you hand it in. If you can staple it, that'd be helpful. You're gonna do a tangent line for a trig function. Yeah. When you turn in your homework, please, don't cram problems on the page. New problem, new page. Right? It's for me. If you need paper, I'll give you some paper. I don't care. Right? If you're worried about having to buy paper, I'll give you paper.